Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss entropy of a two energy level system. Let's begin. To derive the expression for entropy of a two energy level system, we have to consider a system that system have capital N number of independent particles. Total number of and each of this particle have magnetic moment mu, a particular magnetic moment they have. That magnetic moment can be parallel or antiparallel to an external magnetic field. Let me take plus epsilon energy associated with one such orientation. It has two orientation, one parallel, another antiparallel to that of external magnetic field. So plus epsilon is a energy associated with one orientation. Similarly, minus epsilon energy associated with other orientation. N1, the number of particles of energy plus epsilon. Similarly, N2 is the number of particles of energy minus epsilon. So we consider two energy levels. Plus epsilon minus epsilon. It has number of particles N1. It has the number of particles N2. This one is the lower energy state. That one is the higher energy state. The total energy of an isolated system, therefore total energy of an isolated system is equal to energy for that level N1 epsilon, energy of this level N2 epsilon minus N2 epsilon, or E is equal to epsilon as common, that is n1 minus n2 epsilon, or E is equal to, let n1 minus n2 the small n to epsilon, where we prefer small n is equal to n1 minus n2. Taken equation number 1. The total number of particles of the system is n. Total number of particles in the system, that is n, which is equal to n1 plus n2. Equation number 2. If I taken that as equation number 2, n1 minus n2 is equal to small n, n1 plus n2 capital N as equation number 3. Adding these two equations, adding equation 2 and 3, plus n2 minus n2 cancelled out, it will be 2n1 is equal to n plus n, or n1 is equal to n plus n divided by 2. Equation number 4. Subtracting equation number 1, subtracting equation number 2 from 3, subtracting again also without subtracting we can put the value of n1 in that given expression, so we easily obtain the value of n2. Putting n1 value in equation 3, as n is equal to value of n1, that is n plus n divided by 2 plus n2. We have to calculate n2, so n2 is equal to n minus n plus n divided by 2, or n2 is equal to 2n minus n minus small n divided by 2, or n2 is equal to n minus n divided by 2, which is equation number 5. Now capital N1 and capital N2 is evaluated in terms of n plus n divided by 2 and n minus n divided by 2. The total number of accessible microstates microstate of an isolated system which is called the thermodynamic probability W is equal to thermodynamic probability in which way, what are the number of ways through which we can easily arrange these particles. So, it will be n factorial total number of particles divided by n1 factorial into n2 factorials. Taking logarithm on both sides, log W is equal to log n factorial divided by n1 factorial into n2 factorial, or log W is equal to log A by B is log A minus log B, log A minus log B n1 factorial into n2 factorial. Next, log AB, that is log A plus log B formula, log n factorial minus here log n1 factorial plus log n2 factorial. So, log W is equal to log n factorial here minus log n1 factorial minus log n2 factorial. Logarithmic factorial can easily be solved by using Stirling's approximation. We can use Stirling's approximation here. So, we obtain log W is equal to log n factorial is equal to n log n minus n minus again for log n1 factorial n1 log n1 minus n1, here log n2 factorial n2 log n2 minus n2 is equal to n log n minus n minus n1 log n1 plus n1 minus n2 log n2 plus n2 is equal to, rearranging the terms, n log n in that expression minus n minus n1 log n1 minus n2 log n2, in place of n1 plus n2 we write n, as we know n1 plus n2 is equal to n. then plus n minus n cancelled out, n log n minus n1 log n1 minus n2 log n2. In place of n, we can write n1 plus n2. It is n1 plus n2 log n minus n1 log n1 minus n2 log n2 is equal to, expanding that bracket, n1 log n plus n2 log n minus n1 log n1 minus n2 log n2. What are the common terms? Look that expression. n1 log n minus n1 log n1. We can separate these two as n1 log n minus n1 log n1 plus n2 log n minus n2 log n2. In that bracket term, we take common term as n1. Let's choose minus n1 as common. Minus n1 as common. In that bracket, it's log n1 minus log n. No such change. Again, inside that bracket, we take common term as minus n2. Minus n2. So we obtain log n2 minus log n is equal to, from these two terms, minus can taken as common. n1 log a minus log b, log a by b, that is log n1 divided by n. As we take minus common throughout that entire equation, it will be plus n2 log a minus log b, log a by b, n2 divided by n. The substitution we made, in place of n1 as n plus n divided by 2, in place of n2 n minus n divided by 2. These substitutions are put here. Is equal to minus n1 log, in place of n1, that is half n plus n divided by n plus n2 log, in place of n2, half n minus n divided by capital N. Next, log a by b, log a divided by log b. It can be obtained minus n1 as a log half into log the term n plus n divided by n. It is written as n by n 1 plus n by n plus n2 log half into 1 minus n by n. Log AB can be expanded as log A plus log B minus n1 here log A plus log B that minus is multiplied, so it will be minus into log A into B log A plus log B 1 minus by n. The formula log of 1 plus n minus n log of 1 minus n minus n, that can be expanded logarithmic expansion. We write up to 2 terms to the expansion minus n1 log half plus log 1 plus n minus n expansion as n by n plus n square divided by 2n square up to second term. Higher terms are neglected. Minus n2 log half plus that expansion is minus n by n minus n square by 2n square, logarithmic of that term up to second order. Further terms are neglected. Is equal to that n1 is multiplied within that bracket minus n1 log half minus n1 n by n minus minus plus n1 n square divided by 2n square minus n2 log half plus minus minus plus n2 whole into n by n minus minus plus n2 whole into n square divided by 2n square is equal to here log 2 there log 2. From these two terms log half as common, you obtain minus n1 minus n2, so plus n2 within that of bracket log half. Next n by n, there will be n by n. From these two terms we taken n by n as common, we obtain minus n1 minus n2 as n by n. Next that term and this term n square divided by 2n square as common plus n1 plus n2 whole into small n square divided by 2n square is equal to n plus n, that is capital N, total number of molecules, log half minus n1 minus n2 small n into n by n plus n1 plus n2 capital N, n square divided by 2n square. Further simplify it, which is equal to minus n log half minus n square by n plus n square divided by 2n. Next, that is for log W minus n log half, from these two terms n square n common, within that bracket we obtain 1 minus half n square divided by n as common term is equal to minus n log half minus 1 minus half, that is half n square divided by 2n. Negative minus common, n log half plus n square by 2n. This is the value for log W. At equation number it will be 6. So the expression for entropy now we can easily calculate. Therefore entropy of the system is given by S is equal to Boltzmann constant into log of the thermodynamic probability is equal to K log W as minus n log half plus n square divided by 2n is equal to minus nk log half plus n square divided by 2n square, n taken common, minus nk log half log 1 minus log 2 log 1 minus log 2 plus n square divided by 2n square. The value of log 1 is equal to 0 minus nk minus log 2 plus n square divided by 2n square. This is the expression for entropy. See here, as we taken E is equal to n into epsilon, or we can further write n is equal to E by epsilon. There will be no such change. N is equal to E by epsilon. That substitution we can use here. In place of N, we write E by epsilon. So the expression will be changed to minus nk log 2 plus, in place of small n, that is E by epsilon whole square divided by 2n square. That is the expression of entropy. S is equal to minus nk minus log 2 plus half E divided by epsilon n whole square. This is the expression for entropy. Expression for entropy of two energy level system. Expression for entropy of two energy level system. As we taken a two energy level system here, the lower energy level, this is the higher energy level, and the change in energy del E will be 2 epsilon. So with the help of this video lecture, we understand the concept of entropy of a two energy level system. Mathematically we show it. First, expression for thermodynamic probability. Then, by using the definition of entropy for statistical mechanics, S is equal to K log W, we put log W and simplifying it, finally we obtain the expression for entropy of two energy level system. So, with this useful and informative notes, let me wind up the session. Thank you.